Hey everyone, and welcome to this explainer. I am so thrilled to be your guide today. Get ready because we're about to unlock some truly fascinating secrets of geometry together. We aren't just going to memorize a dry mathematical rule here, we're actually going to learn how to measure the real world around us. So let's dive right in.
Here is our game plan for today. 1. Wisdom and right triangles. 2. Unlocking the formula. 3. Solving real-world problems. 4. Your homework challenge. And 5. Education, morality, and peace.
All right, kicking things off with Section 1, Wisdom and Right Triangles.
You know, it's pretty easy to think that learning math is just about crunching numbers on a blank page. But really, it's about gaining a much deeper understanding of our world. Proverbs 2:6 tells us, "For the Lord gives wisdom. From his mouth come knowledge and understanding." The mathematical strategies we're about to cover, they aren't just arbitrary rules someone made up. They are literal tools of wisdom that equip you to connect these abstract concepts to your everyday life.
And honestly, when I say real life, I absolutely mean it. Right triangles are everywhere. Just look at the buildings you walk into, the roads you drive on, even the sports fields you play on. Engineers, architects, designers, pilots, they use this exact math every single day. Every triangle you see out there tells a story, and today you're going to learn exactly how to read it.
Moving right along to Section 2, Unlocking the Formula.
So let's shift our focus to the actual mechanics here. The Pythagorean theorem is amazing, but it has one very strict requirement. It only works with right triangles. That means the triangle has to have one 90-degree angle, kind of like the corner of a perfect square. If you don't have that 90-degree angle, well, then this specific tool just stays in the toolbox.
Okay, now we need to define our terms real quick, starting with the big one, the hypotenuse, which we call side C. You need to lock in two absolutely crucial facts about the hypotenuse. First, it's always the longest side of the triangle. Second, it's always located directly opposite that 90-degree right angle. Think of it like a bridge connecting the two ends of a corner.
Let's visually contrast the parts of our triangle here. We have the legs, that's sides A and B. These are the two shorter sides that physically meet up to form that perfect 90-degree corner. And directly right across from them, bridging the gap, we have our longest side, the hypotenuse, or side C.
And here it is, the famous formula itself. A squared plus B squared equals C squared. It is just so elegantly simple. If you take the length of leg A and multiply it by itself, then take the length of leg B and multiply it by itself, and add those two numbers together, you are always going to get the square of the hypotenuse, side C.
Which brings us to Section 3, Solving Real-World Problems.
All right, you've got the formula down, so let's put it to work with some concrete examples. We'll start by walking through a classic right triangle step by step. Imagine a triangle where leg A is 3 and leg B is 4. First, we write out our formula. A squared plus B squared equals C squared. Second, plug in those numbers. 3 squared plus 4 squared equals C squared. Third, do the math. 3 times 3 is 9, and 4 times 4 is 16. So 9 plus 16 gives us 25. That means C squared equals 25. Now, what number times itself equals 25? Exactly. The square root of 25 is 5. So side C, our hypotenuse, is exactly 5.
Now how about an actual scenario out in the wild? Imagine a kid playing in a park. They walk 6 meters east, and then they take a sharp 90-degree turn and walk 8 meters north. How far are they from their starting point? Straight across, as the crow flies. Well, leg A is 6, and leg B is 8. We square them. 6 squared is 36, and 8 squared is 64. Add 36 and 64 together, and you get exactly 100. So C squared is 100. To find C, we just take the square root of 100, which gives us a final straight line distance of 10 meters.
Now, full disclosure, sometimes the real world doesn't give us perfectly round numbers. And hey, that's completely fine. Take a simple square plot, for instance. Let's say you want to build a fence directly across the diagonal of a square field that's 5 meters on each side. So A is 5 and B is 5. 5 squared is 25 plus another 25 equals 50. So C squared is 50. But when we take the square root of 50, it isn't a perfect whole number, right? It comes out to a decimal, approximately 7.07 meters. And that is the exact length of the fence you'd need to build.
Okay, Section 4, Your Homework Challenge.
This is where you come in. Grab a pencil and some paper, pause this explainer, and write down these 5 scenarios to solve on your own. First, find the hypotenuse if your legs are 5 and 12. Second, find the missing leg if one leg is 9 and the hypotenuse is 15. Third, Test if the numbers 7, 24, and 25 actually form a true right triangle. Fourth, calculate the diagonal of a 6 by 8 rectangle. And fifth, find the hypotenuse for a triangle with 2 equal legs of 10. Seriously, don't skip this step. Practicing is exactly how you build your confidence.
Finally, let's wrap things up with Section 5, Education, Morality, and Peace. Let's zoom out from the geometry for just a second here. Education without morality will hurt. I mean, what is the true point of being super smart and highly educated if you just continue to make bad choices that hurt yourself and the people around you? Mathematical formulas give you incredible power, but biblical morality has to be intertwined with what we learn to ensure we're actually using that power for good.
And the reward for doing just that is profound. Romans 8:6-7 promises peace of mind to everyone who keeps their mind spiritual. When we engage with our education through a lens of faith and good choices, our experience becomes one of true peace as we navigate our learning and ultimately our lives.
Which leads us to this final, provocative thought I want to leave you with today. You now have the mathematical tools to measure and build the world around you. But will you use your moral wisdom to build it well? Think on that, keep practicing your math, keep building your character, and I will see you in the next explainer.